Okay. 1.9 inverse functions. The reason why we did composition functions yesterday is that's what we do to verify functions are inverses of each other and to find inverses. So, actually to verify only. This example on yesterday's homework that Jaden needed help with, when I did f of g of x, what was my answer? X. And when I did g of f of x, what was my answer? X. That means that these two functions are inverses of each other. They undo each other. Like addition is the inverse operation to what? Subtraction. Multiplication is the inverse operation to what? Division. And they're inverses to each other. So that's what these are. We're going to find them and verify them today. So we know that a function is a function if every x value has exactly one y value, correct? Mm-hmm. But its inverse is also a function if every y value has exactly one x value. So what happens in an inverse is the domain of f is the range of its inverse. And the domain of the inverse is the range of the original. If you notice this little power to the -1, that means inverse. Means f and f inverse. And when you see it, you don't say f to the -1, you say f inverse. That is different than saying 7 to the -1st. What is 7 to the -1st? 1/7, correct? It's the reciprocal. This is different. Is that blue okay to see?
Yeah.
Okay. So what physically happens with a function and its inverse is the range and domain interchange places. That's what happens. So if x, f of x was 1, 2, 3, 4, 5, 6, f inverse of x would be 2, 1, 4, 3, 6, 5. What happened? The domain became the range, and the range became the domain. And that goes both ways. They're inverses of each other. So if I gave you a list of numbers, it'd be really easy to do, wouldn't it? But guess what I'm not going to do?
This list of numbers. You could.
I could.
You
I may 1 or 2.
Okay.
You guys remember doing this last year at home?
No.
Discussing it at all?
No.
Yeah. No.
At least one person said yes. All right, let me know when you're good. Okay.
Okay, I'm good.
Okay, which function is an inverse? So, in order for it to be an inverse, I feel like I skipped a bunch of slides. In order for it to be an inverse, we have to do f of g of x, and it must be x. And we have to do g of f of x, and it must be, guess what? X. That goes for h, that goes for whatever, okay? You have to do, because we know already that composition is not commutative, correct? Unless they are inverses of each other, okay? So we got to figure out which one works. So we got to do f of g of x. First, we might as well start with that, right? Okay, so this goes in for what? That x, right? So we get 5 over x minus 2 over 5 minus 2. So it's a complex fraction. Before I do anything, I have to get common denominators and put that denominator into one thing, yes? So what's my common denominator going to be?
10.
How about just 5?
Fine.
Okay. So if it's just 5, this becomes 10, yes? So negative 2 minus 10 is what?
Oh, wait. Negative 12.
Negative 12. Now I have to multiply by the reciprocal, which would be 5 over x minus 12. Yes? And so I would get 25 over x minus 12. Okay, if these were inverses, what did I have to get?
X.
X. Did I get x?
No.
No, I got far from x, didn't I? Now, if f of g didn't work, do I have to check g of f?
No.
No, because both of them have to work. So I could be cruel and make neither of them. So now I've got to do f of h of x.
This one. X.
So we have 5 over x over 5 plus 2 minus 2. So your plus minus 2, what happens to it?
0.
It zeroes out. So I have 5 over x multiplied by the,
Reciprocal.
and the 5's reduce, and the answer is
X over 5.
no,
Why?
because I reciprocated.
Oh.
So it's x. So far we're good, yes?
Yes.
We cannot stop there. We have to do h of f of x. Let me make this really clear, guys. If I say verify these are inverses or are these inverses, you have to do both compositions. If you just do one of them, you will not get 4 credit. The other thing people do is just find the inverse and say, it is. Nope, this is what you have to do.
So even if one of them doesn't work, you still want us to find both?
No, if it doesn't work, it's not. It's not, you don't have to go. But if one works, you still have to do the other one. Okay, so now we got to take this and put it into here, yes? So 5 over 5x minus 2 plus 2.
Yeah.
Okay, well, let's worry about this first. How do we worry about it?
Reciprocate.
So 5 times x minus 2 over 5 plus 2.
So it's
So the 5's reduce, yes?
so
And plus 2 minus 2 is
0.
0. And so it's
It's an inverse.
x. So h is the inverse of f, and f is the inverse of h. Now, what did you notice different about when I did these? When I did f of g of x, which I erased some of it, did it kind of just fall apart nicely? No. But when I did f of h and h of f, they looked horrible when to start, but then they just fell away pretty nice, didn't they? If they're inverses, they should pretty nicely just kind of work their way out. Questions?
No.
Okay, show that G and F are inverses of each other. Algebraically and graphically. So first of all, we're going to worry about algebraically. How do I do that algebraically? How do I show they're inverses of each other?
Put F in the G of X. I've already done.
So we do F into G of X and
G into F of X.
G into F of X. So do it.
I did.
Both of them? Oh, these were really easy, weren't they? So you get x plus 5 minus 5 gives you x. And then x minus x minus 5 plus 5 gives you what? X. They are not all going to be that easy. But now graphically, if you guys want to put these in your calculator, you're more than welcome to do so. I would probably give you grid paper. But okay, so these have a slope of 1. Yes? This one has a y-intercept of 5, and this one has a y-intercept of, wait, this one's negative 5, this one's 5.
Yeah.
So 1, 2, 3, 4, 5. That's the y. What's the x-intercept? The x-intercept would be 5, wouldn't it? 1, 2, 3, 4, 5. Okay, there's one of them. And then 1, 2, 3, 4, 5. And I bet this one's negative 5. What do you bet? Looks like an error. Okay, so are these inverses of each other? I don't know.
Yeah.
Haven't told you how. Anybody remember how they're inverses of each other?
They both equal x.
Are they a reflection across that line?
Yes.
Yeah. All inverses reflect across the identity line, the y equals x. Remember that parent function that it showed in the book, the identity line? That's why it's called the identity line, because inverses reflect across it.
Wow.
So you could have a funky graph that looked like this. And so then if it reflected across it, it would look like this. Is it reflected across that line? Yes. Okay. So the linear ones, make sure you're able to graph them. Probably quadratic too. But everything else you can throw in your calculator. I just want you to see what is the relationship every time they're inverses. They're reflected across the identity line, the y equals x line. Y-intercept is 0 and slope of what? 1. Pretty easy stuff, right? Okay. Am I good? Okay, does a graph have an inverse? The function, is it a function? How do I know if it's a function?
Vertical line.
Vertical line test. So yes, it's a function. Does the function have an inverse? And we should add function to that. Now, everything has an inverse. Not everything has an inverse function. Get what I'm saying? Everything I can take the x and the y's and go, whoop. Yes, there's nothing stopping me that. But is my inverse also a function is the biggest question. So, if it passes the vertical line test, yes, it's a function. If it passes the horizontal line test, then its inverse is also a function. I hate when books tell you that it has no inverse if this doesn't happen. No, it does. It doesn't have an inverse function. Get the difference between what I'm saying, guys. Okay. That means it is 1-to-1, and we've talked about 1-to-1 before. 1-to-1 means every x has one y, and every y has one x. That's all 1-to-1 means. It passes both the horizontal and the vertical line test. All three of these graphs are functions, yes? Are they all functions?
Yes.
Yep, they pass this vertical line test. Yes? But are there inverses functions?
No. Yes.
Okay, so the only one that is 1-to-1 is
The middle one.
the middle one. Not that you can't find the inverses of the other two. But now, what if I took this function right here, this first green one, and did this? And I only said that much of its domain. Is it now? Yeah. This is a horrible sine curve. And when next semester we will take it and we will say nothing exists except from there to there. Does this now pass both the vertical and horizontal line test? Yes. So you can take a function and limit its domain and make it 1-to-1. But the middle one is 1-to-1 naturally. Make sense? Come. Oh. Yes. This one's inverse. And see, it says, does it have an inverse? Again, guys, they both have inverses. But this doesn't have an inverse what? Function. Okay. Here's a table of values, finding the inverses. I showed you on the very first slide, if I have one, all I have to do is to the points is do what to get to the other one? X's become what? Y's, and Y's become what? X's. So all you have to do is take the points and reverse them and plot them and do these two lines reflect across the identity line. Yes. That's it. Do we need any more on that? Okay. Are those inverses? Yes, they are reflected. At some point, most, not all, most will intersect on the identity line. Most, not all. Okay, so find the inverse function. You need to interchange the x and y values. Ooh, I'm still on that big old marker. To find the inverse, you interchange the x and the y and solve for y. Okay, so to find our actual equations, we're going to interchange the x and y, solve for y, and then we're going to do our check. And I really don't know why there's that big gap between there. But this says f inverse of x, and then f of f inverse of x, and f inverse of f of x, correct? Same as f of g and g of f.
What is a -1 for?
Inverse.
Okay, that makes sense.
I said that a few times. Okay, so find the inverse. So what was the first step that it told me?
Interchange the x and y.
But there's no y there.
Whoa.
Is there?
Oh no.
Is there a y there? Please tell me yes.
Yes.
No.
It's
It's the f of x is the y. Thank
I'm a
you.
genius.
I was really scared.
So x equals
So,
7y
X
plus 4.
equals 7y
There you go.
plus 4. Then what did it say to do?
Solve for y.
Solve for y. So I'm pretty sure we would subtract 4 and divide by 7. So we're saying this is f inverse of x. Yes?
Yes.
So now what do I have to do? On the last slide, what were your 3 steps?
Check.
The check, the verify. So do it real quick. We better get what both times? X. Takes longer to write out the problem than to simplify it, I think. Did we do it right? Did we do it right?
I'm confused now.
Yeah, same.
Why?
Because what did you do on the second part? The second
So I put f in there, so I have 7x plus 4 minus 4 over 7. So that zeroes out, so it gives me 7x over 7, and that reduces to 1, and so the answer is x.
Okay, I understand.
And on this one, these reduce to 1. These reduce to 0. Because you would have x minus 4 plus 4, and you get x. Now, I have to do those in the correct order? Yes, but do they reduce out?
Yes.
Yes. Be careful and don't just start crossing things out. Because sometimes people do that and they'll say, yeah, it's an inverse, and it is so not an inverse.
I like just crossing things.
I know, Bladen.
Like my whole page.
Cross out the whole thing.
Okay, find the inverses of both. Let me see how far. Okay, I just have examples of finding inverses. My examples, they just get weirder equations, yes? Okay, so we're not going to verify, we're just going to find the inverse. So the first thing we do is what?
Set it to y.
Set it, so it is y and then interchange, right? So x equals 5 minus 3y over 2. And the next one is going to be x equals the square root of 2y minus 3. Now both of them you need to solve for y. Matt, how'd they go? Bladen?
I'm still doing it.
Okay.
Who's over there?
It's a fly thing. The person flying over there.
Yeah, I think you are.
Jaden?
I don't even know his mom's good.
Santa, how'd you do?
Punch him on.
I got confused on the way that you wrote it in there.
Yeah.
With the negative.
Yeah, that's what I was going to ask you. On this first one, do you guys see what I did?
Yeah, but I didn't do it like that.
You don't have to. I cannot stand negatives in the denominator. I forget them. So I just put it up through the numerator. But do I have to do that? No. I just tend to forget them in the denominator. I don't know why. Jaden, where'd you get stuck?
I don't even know. You lost me like when we did the last one.
I squared both sides to get rid of the square root.
Oh, I kind of got that one.
I just started to confuse myself
Yeah.
when like putting it into the like to check if it's
I got it right, I just
Right.
didn't know if you could just make the twos the squares. I didn't know you could just make those appear.
Well, as long as rule of thumb is I can do anything I want to an equation as long as I do it to what? Both sides. I can do anything I want to a fraction as long as I do it to both the numerator and the denominator. So I'm not changing it as long as I do it. I'm just rearranging what it looks like. Okay, let's try it again. So what are we going to do with this one? You guys want to do these on your own again?
no.
No? You want to do them together?
Yes. At least the first one.
Okay.
I'll attempt the second one.
So then we should have x equals the cube root of 10 plus y. Yes? Well, how do I undo a cube root? I cube it. I cube both sides. So I get x cubed equals 10 plus y. So then y would equal f inverse of x, which would equal what? X cubed minus 10? I was like, where did we get 10 cubed? That's a funky x. It's an R.
Which one?
Wait, how'd you
The
get
little
x
tail?
cubed minus 10? Just took it
Yeah, because I'm solving for y.
up.
Now. Sure you guys want to do this one on your own?
Yes.
Okay, go for it. Be brave.
I don't know anymore. That's right.
Try something. What made this one hard?
XY.
The xy. Did you all multiply over by the x or the y plus 2?
Yeah.
The first thing you should always do with the fraction is multiply over by the
I was
denominator,
trying to do it on
correct?
one side, not the other side.
Right. So then I have xy plus 2x. Then I'm solving for y's, so I get my y's on one side and everything else on the other side.
Wait, how do you
Yeah,
get?
y equals xy plus 2x plus 3.
How do you get 2x?
You have to distribute.
No.
So I get 2 y's on one side. If I have 2 y's and I want 1 y, I can factor out a y, can't I?
Yeah.
Yeah. So then I can divide by the x minus 1. So I have 2x plus 3 over x minus 1.
I just get confused, like, putting it into the thing, but after, like, I get past so far, I can get to the end. It just confuses me. That's weird.
Because it's weird to have y there for us to solve for it like that. That's all I got for you. and all you're doing today are finding inverses and verifying inverses.
At the same time.
So is this binding inverse?
Yes,
How many we got left?
And then the other thing is
verifying.